Okay, hello everyone. So in this video, we'll continue with the second demo of PurpleSharp Adversary Simulation Tool. So in this demo, we'll go over two new tactics: discovery and defensivation. So as an attacker progresses on a breach, they will most likely engage in these tactics to obtain information about the environment or bypass controls. So in this case, as far as discovery, we'll go network share discovery, network service scanning, and then domain account discovery. And then for defensivation, we'll execute process injection simulations, particularly portable executable injection, as well as clear Windows event logs. As a reminder, we are executing these techniques in a Windows domain environment from a domain joined computer, and all the data is going through Splunk, which we're gonna review. Okay, so we'll jump straight to the demo. So in this case, we're gonna execute the demo in a different way. So as I was writing PurpleSharp, I reached out to the community and friends to get some feedback, and Olaf Harton gave me an interesting feature request. So we needed a way to execute playbooks without using the command line, and instead using something more flexible that maybe could allow you to automate things. So I came up with this feature of executing playbooks using JSON files. So for more information about the syntax, please go through the documentation. But this JSON file will execute two simulation playbooks. The first one against Windows 10-1, and it's going to execute two techniques. It defines where we're going to upload the scout and the simulator. It's going to wait 30 seconds between each of these techniques. And then on the second simulation playbook, named Discovery Simulation Playbook number 2, we're going to execute it against Windows 10-3, defining different paths, and then we're going to execute the account discovery technique. Okay, so we'll go to PurpleSharp and pass the PB parameter with the JSON as a parameter. It's going to ask us for the password of the account. Okay, so it's going to start executing these two playbooks. So I'm going to stop the video for the sake of time and come back once it's finished. Okay, so it finished. So we'll go back app, and as you can see, it first executed the first playbook, executing two techniques against Windows 10-1. It provides similar headers and information about the techniques as we have seen before. Then it waited 1 minute for the next playbook as per our JSON that wanted to wait 1 minute. And executed the other technique against Windows 10-3 and finished, and it also wrote the results. So we're gonna open the results on Notepad++. So we see here the results, and then we're gonna use this to format the JSON. So as we can see, we received the results of these simulations here in JSON file, which makes it really easy to ingest, right? In this case, we see that the simulation ran under context of M Simpson. It ran under this path with this process ID, so we can always use this information to correlate with our logs. And then each task will have some results. In this case, it was successful. The network share enumeration, we get the time, and we can see some debug events for debug messages for each this technique. In this case, it's using the Windows 32 API netshare enum to enumerate shares. It randomly query LDAP, randomly picked 7 targets, and run the network share enumeration against these targets, which we'll see in a bit. And then it executed the port scan technique. It was successful. It used system.net set sockets. It once again obtained 7 random targets on the network and scanned them. Okay, so let's see what the looks look like for this. Okay, so for this first network share discovery, we're gonna go to Splunk. In this case, we're gonna use the event 5140. Actually, okay, I had to change the query a little bit. So in this case, we're looking for 5140s from the address of 151, which is Windows 10-1. which is where we run the simulation from. And as you can see on the events that we just got for 10.06, we were able to correlate what PurpleSharp did, and on this host, they were enumerated, and we can see here the IPC $ share was accessed from against this host from our Windows 10-1. So once again, if you want to build a detection for an attacker, maybe trying to enumerate shares, you can use PurpleSharp to obtain the telemetry and maybe test or create your detection. Okay, and for the next simulation, in this case, the port scan, as you can see, it ran at 10.07. PurpleSharp was able to run a network scan or a port scan against this host. So if we go to Splunk and we use event code 3 from Sysmon, we're going to see some interesting events. So as you can see here, this the simulator that was running under the context of Mark Simpson under this path actually port scan against RDP and 445 against all these hosts. So if you have Sysmon, you could create a rule to detect an endpoint doing network port scanning, or maybe if you have network telemetry like NetFlow, you could also try that and use PurpleSharp to see if your detection is working, or maybe you have some kind of NTA, network threat analytics. You could also test that. Okay, and then the last simulation of this playbook was just an domain account enumeration. In this case, we see that the net user / domain command was executed. This is typically used to discover who is who in the domain, and we can see from the logs on Ubuntu once again that first we had the service, the scout running, then the simulator running, and then the net commands executing here. Now, one interesting thing is that PurpleSharp can execute this technique in two different ways. We executed one of them, which is like the simple net user / domain, but there's a more interesting one that I have implemented that uses LDAP. It runs LDAP queries to execute the account discovery. So you may be able to detect the first one with just Sysmon or some kind of EDR, but maybe for the second one you need something more on the network, like maybe an ATA or a tool that is sniffing for LDAP traffic. So PurpleSharp will be able to test both. Okay, and for the next simulation playbook, we're going to execute this second JSON file. In this case, we're going to execute this technique, which is process injection. And then we're going to clear the event log. The first one runs against Windows 10-3, and the second one against Windows 10-2. Okay, so we're gonna give that a try. We're gonna pass this. That doesn't exist. Okay, so I'm gonna stop the video and then come back when it finished, when PurpleSharp is done. Okay, and it just finished now, so we see the results here. So we're gonna open up the results JSON file to review that. So it's gonna go here, and we're going to format the JSON. Okay, so as you can see, the first playbook executed against Windows 10-3, it executed one technique, which is the process injection. And on the debug logs, you can see what PurpleSharp did. It first started a process, notepad.exe, and then it called the typical Windows 32 API calls to inject malicious code, open process, virtual alloc, write process memory, and create remote thread against this process. So let's see how that looks like on Sysmon. So we're gonna run this query. No, we don't want this. And we're gonna sort by time. Okay, so as we can see here, this actually runs. So let's check on the times. So this was at 10:19, 10:18. Let's take a look at this. So as you can see, it matches the times. So first we see the scout agent running once again. You can see that the simulator is running, and then you can see here event ID 1 for process starting. Event ID 8 is on Sysmon create remote thread. So as you can see, the source image was the simulator tmp12345.exe, and then it injected code into notepad.exe. So we did successfully detected this injection, and in this case the shellcode that we injected, all it does is just executes a simple ping command. So with PurpleSharp, we have been able to easily simulate a process injection, and with Sysmon we can detect it. So again, the question is, can you detect these attacks if they run against your network? And one easy way of doing that is testing that it's using PurpleSharp. And now we're gonna run one last query. We're gonna run this query, and on the results of the playbook, we see that the second playbook executed again, Windows 10-2 running as system, and then it deleted the security event log using the command line. In this case, use the command line. And as we can see here, around that time, we can see this event 1102 where the audit log was clear, the security audit log was clear. So once again, PurpleSharp allows us to simulate an attack in a real computer with real users in a really easy way. And one last thing to mention, again, I would want to be able to execute the same technique in many different ways, or at least in two ways. So I can do clear event logs using the command line, just like as we did with this command, or we can also use .NET, and in this case we're going to use just event log.clear and close. So can you detect both, or just one, or none of them? You can use PurpleSharp. Okay, so this concludes demo number 2.